In this video we're going to be looking at transpiration in plants and ways to investigate that rate of transpiration. Now we've got two different ways of doing this, a teacher demonstration and a student practical, both using a device called a potometer. So this is our teacher's demonstration one. This is a Gangong's potometer, and it allows us to actually see how much water a plant's taking up, and then allows us to experiment and do different things to the plant to see if that increases or decreases this rate of water uptake into the plant. So the potometer is the ideal piece of equipment for this. But the problem with transpiration practicals and using a potometer is they can be quite fiddly to set up, and there can be quite a few things that go wrong with it. This often leads to teachers and technicians not bothering and just teaching the subject from the book, rather than actually giving it a go and getting pupils to actually play with the device and actually see what they can do to change that rate of transpiration and that rate of water moving up into the plant. Now, this is a key part of the GCSE curriculum, and a really nice plant practical that has lots of sort of context in the real world. So, for instance, if we look at the Amazonian rainforest, the clouds above the rainforest, the majority of water there comes from the plants, comes from this transpiration, the water leaving the plant somewhere. And in this practical, we can investigate where that water is coming from, where it is leaving that plant. So we have our teacher's demonstration potometer here. So we have a glass vessel, two parts connected with a bit of rubber tubing. We have a piece of capillary tubing here, which is where we put a bubble or a bit of food colouring in, just to see how much and how quickly the water is going up or going down. We have a reservoir here, which allows us to move the air bubble up and down, or the food colouring, so we can reset the practical to do different experiments. And we have a vessel part here, which is where we actually put our plant into. So what should happen when we put our plant in, the water leaves the plant and then takes up some more water along this device here, along the capillary tube, where we can insert a little air bubble, and that should travel up towards the plant, and then we can measure different factors that affect that rate of transpiration. We also have a crystallizing dish here, which is going to act as a reservoir, so I'll keep on taking water up with our food colouring or an air bubble. Some Vaseline to seal the plant up here, some water, and if you want to use food colouring rather than an air bubble. So when it comes to the potometer itself, the difficult thing with this is getting the seal at this end. Without a seal, the water will just flow back into the reservoir. So we need a good tight seal here. So for this, we're going to use a bung with a single hole in. This will be inserted here, and the plant itself will go through this bung. Now, I'm going to use laurel. Laurel's really good for this. It's also very easy to find. It's in gardens, parks. It's probably in your school grounds as we speak, just sitting there looking a bit ornamental. But what we can do, and what's really good about this, is it has a nice hard woody stem which allows us to put it through the bung quite easily. So, I'll just put that back in there for a second. First thing we need to do is fill our potometer and our reservoir with some water. Ordinary tap water is fine for this. Now, I'm not going to fill this all the way up yet, because I just want to make sure that we get rid of any air bubbles in the potometer. So we've got rid of that one there, and just make sure we squeeze this bit of rubber tubing to get any water out this end, and air bubbles, there we go. So just close that tap there and just re-top that up. So we're nearly ready to go. But you can probably already see that we're losing water already. And if we don't have a seal up here, it doesn't matter how strong the plant is and how much transpiration is happening, it won't keep up with that water going down, so the gravity forcing it back. So we're going to take a bit of laurel. I'm just going to insert it into the bung, and when you're picking your piece of plant, you want to make sure that the plant is just that little bit thicker than the hole in the bung. So it means you get a really tight seal, a good fit with the plant. So we put that on there like so, and I'm just going to snip off the ends, make sure we get rid of any airlocks there within the stem itself. Then we top up our potometer all the way to the top. Doesn't matter if you make a little bit of a mess here. And put that straight in, like so. Really, really tight. And then, rather quickly, we just need to get some Vaseline to make sure we can seal the top of that bung off. Now, hopefully, if the plant itself is quite a tight fit, there should be quite a good airlock, a good sort of seal in there, but that Vaseline will just help, just in case. So, that should be it in terms of trying to get our plant in there. Now, what we need to do is see if we've managed to get a seal and to see if this plant is actually taking up water. So, what we need to do is just lift up the potometer and just squeeze out a bit of the water into our reservoir, and then just let go of that rubber tubing, and we're going to get an air bubble in the system, just in the capillary tubing, and then lower it back into the reservoir so that air bubble was now again followed up by water. There we go. Now, what we should have is a seal here, and you can see there's no water coming through. So that means this seal's quite tight. If there was air getting in here, the water would be going down. We've now introduced our air bubble, and the air bubble is just here, and you should just about see it move, hopefully, if it works. And looking at it, it looks like it's just going up. There we go, it's just gone up one division and another. Now, when you set this up, if the air bubble you put in goes back into the reservoir, go back into that crystallizing dish, that means you haven't got a seal here, the water's going back into the reservoir. If when you put an air bubble in, it just stays where it is, it means that there's either air bubbles in the stem or the plant itself isn't transpiring at all. And that could be because it's been, I don't know, taken out quite early in the morning, it hasn't really got going during the day, it could be quite cold outside, so it hasn't got to room temperature, for instance. But if the bubble's going up, it means your plant is transpiring and that water is going into the plant. So the plant is losing water up here, so losing moisture in here, and that water is now being replaced by water from the potometer. And that is going up, and it's going up quite nicely. Just there, you can just about see that going up now. Now, air bubbles are quite nice because it gives you a definitive line to actually measure from. So it's quite good for student potometers, but often in a class, trying to get 30 pupils around your potometer just to see an air bubble can be quite difficult. It's quite hard to point it out. So you could use food colouring instead, and the food colouring will again just rise up through the capillary tubing, and you'll be able to see it's much more visual using food colouring, so that could be another option for the class. Now, we've got it working, so what do we do now? Well, we can experiment on the potometer or on the plant and see what happens. So we can come up with some ideas about where this water's leaving the plant. It could be through the stem, it could be from the leaves, it could be the underside of the leaves, the top of the leaves. We could look at different factors that could increase or decrease the rate of transpiration. So, for instance, common practicals or tests you could do with the plants is to put Vaseline on the stem, because the Vaseline would seal off any stomata or any other parts of the plant where water could leave. We could do the same, put Vaseline on the underside of the leaves, the top of the leaves, all around the leaves, and see if that has an effect on this bubble and how it moves up. You could also put the plant into a plastic bag with some desiccant, so we dry the air out and see if that increases or decreases the rate of the water leaving the plant. You could also use a classic, this is probably the most common one of the potometer, is using a hairdryer. So drying out or heating the air around the plant to see again if that increases or decreases the rate of transpiration, so it's water leaving the plant, and how does that have an effect on the uptake going through the potometer. It's a really nice topic and really links into things like agriculture and plant biology and how we can use plants in a more effective way in agriculture to increase, for instance, food crops and the yield we get from them. But it is really nice and simple, and the good thing about the Gangong's potometer itself is that it's quite, once you've got a hang of it, it's quite easy to set up. You don't need to submerge it, and it can be done in the lesson where the pupils are actually watching it being assembled. The second piece of equipment we're going to look at to measure the effect of transpiration is a really simple student potometer. Now, all it is a bit of capillary tubing with a bit of silicone tubing here, and we put our plant in the top like so. This has to be submerged to make sure we don't have any air bubbles in it, so it can be slightly more complicated to set up than the Gangong's potometer, but we'll go through it step by step, and hopefully you can see how useful it would be for actual students to have a go at the practical itself, which can often embed it in a much better way. So, what we're going to do is we're going to take our potometer, our student potometer, and place it in a tray with some water in it. So, just like so, just plopping it down into the tray. Now, to make sure we get rid of all the air bubbles within this potometer, I'm just going to use a syringe. Now, I'm just going to take our potometer and just use the syringe, and you can hopefully come and see it coming out the other end there. Use that syringe to just get rid of all the air bubbles within that potometer. Sometimes you might need to just squeeze the silicone tubing as well at the top. So you might need a couple of goes, just blast through and get rid of all that air. Like so. Okay, so that's most of the air bubbles out of that potometer now. Just got one that wants to stay there. I think that should be okay. It's not all the way around. So, we've now got our student potometer in there. It's nearly full of water and only one air bubble in there, and I think we can live with that. And then I'm going to take, again, I'm going to use laurel. This is my favourite plant for the potometer. Now, you don't necessarily have to, but sometimes it's worth just sort of snipping off the end of the plant underwater to make sure there aren't any air bubbles in there, like so. And then what we're going to do is carefully insert our plant into that top of the silicone tubing. Now, I've made sure I've picked a plant that's a good tight fit, so we get that seal, because again, even with this type of potometer, the seal is really important. And then just get some Vaseline and just around the top of the plant, where the plant meets silicone tubing, just to make sure we get a seal, like so. Now, hopefully, we've got our seal, so what we're going to do now is put it into this clamp stand, like so. We've got a capillary in there, like so, just clamp that. So what we have now is we have a student potometer, so a piece of capillary tubing with that bit of silicone tubing. Our plant's in the top of that silicone tubing, it's all flooded out with water, and we've got some Vaseline at the top there, just to make sure we've got a seal. At the bottom here we have our crystallizing dish, and that crystallizing dish just has some water in it. Now, might just need to clamp that a bit more, make sure it doesn't fall over. Sometimes it can be a bit fiddly. Okay, that should be okay. Now what I'm going to do is just add some food colouring to the bottom, or around the bottom of that capillary tubing, our potometer, like so. Now, Again, with the gallons potometer, what we need to look out for is whether or not we've got a seal here. So if we start seeing air bubbles here, it means we haven't got a seal and the air is going to push that water down. If we don't have anything coming up, it means that there's no air bubbles. It means that the plant just isn't working, so there might be an airlock in the stem. But if we start to see the food colouring moving up at a considerable rate, we can actually show that process of transpiration is happening. And actually, we can now see, even after a few seconds, can you see now that we've got this red line within our capillary tubing shooting up, and there's a little air bubble there as well that's moving up quite quickly with it. But you can see now how, especially here, we've got really strong red food colouring going up. So we're showing that we've got transpiration happening. We're losing water out at the top here, and that's drawing water up to the plant. Now, with this potometer, students can see the transpiration happening. They can set it up themselves, they can have a go. But it is sort of one use. Once this happens, your food colouring's up there, you can't really start experimenting with it. But what you can do is, by actually introducing a three-way tap here, is then use a syringe to flood the food colouring back down so you can start again. Once you can do that, you can then start repeating experiments. You can try coating the leaves with Vaseline, or the stem with Vaseline, for instance, to see if that has an effect on the transpiration. Or, as we mentioned earlier, using a hairdryer or a bag to dry out the environment to, again, see if that has an effect on the rate of transpiration. This is a really nice, very simple potometer. It is a bit limited in terms of the experiments you can do with it without that three-way tap, but just for pupils to have a go at constructing the potometer and actually seeing the transpiration happening and the liquid going up into the plant is just a really nice and quite effective way of teaching the topic.